When you first look at these two questions, you might be thinking that they're super easy, but let me tell you, no, they are not. They are actually super tricky. And the reason that they are super tricky is because they look super easy. So if you look at the first one, we have the inverse cosine of original cosine of pi. And for the second one, we have the original cosine of the inverse cosine of pi. Isn't that the inverse and the original just cancel each other out? So for the first one, we should just be getting this back, which is pi. Likewise, this and that cancel, we just get pi as well, right? No. In fact, for the second one, we actually do not have an answer. And it's actually just lucky that for the first one, this and that can legitimately cancel and we get the pi back. So why is that? Well, here are all the details that we have to talk about, and the main topics of all this is because of the domain, and specifically it's the domain to have inverse. So have a look right here. Let's take a look at the graph of cosine. So if we do that, then of course we know that it starts right here, right? 0, 1, and then just kind of go down and then up and so on, so on, so on. The problem with this is that, you see, this graph, when we have y is equal to cosine, the domain is all real numbers, but this is not one-to-one if you look at the whole thing. Meaning that if you draw a horizontal line, the line will touch the graph more than one time. In fact, infinitely many times. And that's bad, because when we want to get the inverse, meaning that we have to do the reflection about the line y is equal to x, the inverse wouldn't be a function anymore. So this is what we have to do. Instead of looking at the whole thing, we're actually just going to cut a piece out and then do the inverse. And this is how we are going to do it. We are going to start right here, 0, 1, and then we are going to go down to here. Well, this right here is 0, 1, and then this right here is when x is equal to pi, and then the y value here is -1. If you just focus on this portion here, this is one-to-one, and then we can just do the reflection, and then we can get a really nice inverse. So let me write this down right here. The domain of the original is -infinity to positive infinity, but the key right here is that we want the domain to have inverse. Otherwise, if you just do this, then it doesn't make sense. We have to restrict just the red part. The domain to have inverse, it will be from 0 to pi, and including both endpoints right here. Alright, and then the corresponding range, as we can see, is just going to be from -1 to 1. Alright. So how does this help? Well, first off, once we know the domain and also the range for the original, we should also know the inverse right away. So let me just put this down right here for you guys. If we have the inverse, which is going to be the notation like this, right? In that case, the domain of our inverse, in fact, is just the range of the original, because remember, x and y get switched. And that's the main thing for the original and the inverse. So for the domain for this guy, it's just that. So let's put that down, which is -1 and 1, right? And then its corresponding range, this is actually really nice because we have that right here already. It's going from 0 to pi, including the endpoints. So that's what we have. Okay, then how are we going to utilize all this? Here's the thing. It depends on the order of how we do the composition of the functions. This right here is the original cosine inside, right? So let's do that. I'll just put down a note right here. In order for us to have the inverse cosine and the original cosine to cancel and just get the x back, this right here is only true if, you see, because we have to do the cosine x first. So we have to refer to the domain to have inverse. So this right here is only true if x is in between of 0 and pi. So let me just write that down right here for you guys like this. And if we do it the other way, if we have the original cosine on the outside and then the inverse cosine on the inside, if you really want to cancel them out and get the x back legitimately, well, for this right here, we will have to focus on the domain of the inverse cosine, which is actually going from -1 to 1. So this right here is only true if x is in between of -1 and 1. So have a look right here. Why is the second one wrong then? Well, we know pi is about 3, right? 3.14 to be exact. Not really, that's not exact, I just lied. But anyway, it's about 3.14, yeah. I really don't know much. Okay, take a look at pi. Well, we know that pi is approximately 3.14 and so on. But more importantly, pi is bigger than 1, which is outside of this interval. So in fact, this right here doesn't even make sense in the first place if you are talking about real numbers. So this right here is actually undefined. We do not have an answer for this. Why? Because again, it's out of our domain. Of course, cosine of undefined, it's not you can just cancel it. No, don't do that. Cosine of undefined is still undefined. So in fact, the second one right here, the answer is actually undefined. That will be for the second one. And for the first one, have a look. Here we have cosine pi, and pi is in fact in between of 0 and pi. So for the first one, we can actually legitimately cancel out the inverse cosine and the original cosine, and we get a pi back. So this right here is legit. So definitely know the details, and this is for cosine, and you can imagine similar things will happen for sine and tangent and the other inverse trig functions and their corresponding original functions.